Was data journalism.
Data journalism and then lunch. Hi, everyone. I'm back. All right, so we're going to talk about data journalism for elections and beyond. I'm going to start off with this game that I like to play. It's called Guess the Data. I have an interactive map here. I took a screenshot of it. I got rid of the headline. I got rid of the key. But I want us to kind of warm up into data journalism by playing Guess the Data. So I want us to all to look at this map and kind of talk through what this map is showing. Everything on the map is there for a reason, all right? So let's just kind of start looking at all the different parts. Does anyone want to start with what are the yellow lines on the map? Go for it. Time zones, okay. So the lines break down the time zones: West Coast, Mountain, Central, Eastern. Does anyone want to take a stab as to what this data set might be? Go for it, right over there. Viewership of some television event. That's a good guess. Any other guesses? Closing times? Okay. We're getting really close. Notice how the colors, we call this a chloropleth map or a heat map, where the color of, we have counties here, are darker depending on some kind of variable, right? Population centers. Okay. Yeah, one more. Say that one more time. Broadband internet access is getting really, really close. All right, so, we'll take one more.
Well, I'm kind of looking at it differently.
Sure.
Thinking that it's not any of that. Because if you look at Colorado, there's a dark area
Right,
in a part of the state that is plains,
right.
where there's absolutely nothing but cows.
Are you talking about this area? Right.
And then you have the Front Range of the
Right.
Rockies. And then you have
Oh, right here, right here.
yeah.
Yeah, I knew that. I'm good at geography, guys. Right, okay. Well, okay, and let's look at Nevada real quick. Las Vegas, very black, right? And the rest of Nevada is there's not much folks in Nevada otherwise. But the time zones obviously have a big play in this, right? So the answer is, well, does anybody have a Fitbit in the room by chance? How many folks, you have a Fitbit? A couple folks have Fitbits. Does your Fitbit keep a track of when you go to sleep every night? They kind of tell you that. I think some Fitbits do that. So this is a map of average bedtime by U.S. county. So the Las Vegas thing makes sense now, right? And you see how the time zones play into the color on the map, right? But this is not Fitbit. This is a company called Jawbone. Jawbone doesn't exist anymore, but they used to have these fitness trackers that also kept track of when you go to sleep, right? And I bring this up because it really leads us into data journalism, because we're talking about data journalism now because there's more data than ever, right? There's more data than ever, and it's because of technology, right? We have, fitness trackers that keep track of our heartbeat, of what time we go to sleep. We have Facebook that keep tracks of everything else in our life, and a lot of different other data sets, right? So that's why we're seeing, more data journalists, more data reporters in newsrooms, and more data reporting in general, right? So how many reporters actually use data? 42% right now, according to this really large survey. 42% of reporters use data to tell stories regularly, right? More than half of news organizations in the U.S. have data journalists, dedicated data journalists in the newsroom. Who works with data here in the audience? Couple folks? Awesome, okay. So today, with this session in data journalism, I'm going to talk to you guys about a few tools, a few Google tools that will hopefully get you started with working with data. If you don't work with data now, I'm sure you'll work with data sometime in the near future. So we want to equip you with the tools that will help you get started, right? And to not be stuck with, say, uploading data, downloading data, finding data, but actually to begin asking questions of the data that you'll probably get, all right? So what are the subjects that require the most data right now? Obviously, politics, that's why we're here today. Politics, finance, investigative reporting, but sports too, right? Sports, a lot of data in sports. There's data in everything now. And just quick tangent. There's a data set on a lot of wild things out there right now. Not in addition to average sleeping time, but I teach data literacy and data visualization at Fordham in New York, and I start off my semester every semester with kind of just surprising students with all the different data sets that exist, right? So we have average bedtime by U.S. county, but we also have a large data set on average pigeon speeds. Right? There's a huge data set on how fast pigeons fly all over the U.S. There's a data set on the optimal chopstick length for pinching efficiency. My favorite is someone did a study on LSD and the impact on math tests. And to no one's surprise, the more LSD you take, the worse you get at math. So there's a data set on just about everything. I think in the first session with advanced search, I talked about a few ways to find data, right? So we could go file type CSV, file type XLS, and whatever data set that we want to look for, right? So there's a lot more easier ways to work with data. Now we're going to talk about how to work with data when you download it and start asking questions of it, okay? So here's the agenda for this next hour before lunch. We got Google Sheets, Google My Maps, Google Trends, and then a few specific tools for the election data bot, tilograms, and data GIF maker, okay? So let me go through this couple slides as well. I talked about a lot of tools that we'll talk about in this session, but know that data journalism is a process, right? If you work with data, if you work in data reporting, data visualization, or data journalism, you know that it's a process, right? We find the data, we have to clean it, we have to ask it questions, verify it, and then we start analyzing it, making visualizations, and making kind of the final product that most of us see in the New York Times, the Washington Post, or all other kind of news organizations, right? And there is a Google tool for every single step of the way, right? So in the first session, I talked about how to find it, right? Defining it, finding it in Public Data Explorer, playing around with it. And then we have things like verifying it, cleaning it with Google Sheets, Google Refine, analyzing it with a visualization software. We're going to talk about Google My Maps, and then all different ways to present it at the end, okay? So most importantly, data journalism is a process. So let's start talking about Google Sheets. But before I actually jump to our Google Sheets presentation or our hands-on, I want to talk about a few definitions that I think are really important for us to start working with data. And the first thing I'm going to talk about is scraping data. Has anyone heard the term scraping data before? A lot of folks are shaking their heads, right? So what is a true definition of scraping data? This is kind of a definition that I share, but it's essentially copying and pasting structured data. I'm going to explain structured data in the next slide, but it's copying and pasting structured data from a web page, right? But instead of doing it by hand or having an intern go through a web page and copying it line by line, we use software or code to automate the process, all right? So scraping data is copying and pasting data from a web page and doing it automatically. And then you could obviously do this through intervals, right? So if a page gets updated, say once a day or a couple hours a day, you could set your little script or your little robot to copy that data every single interval, right? So I mentioned code here, and I know it's probably freaks a couple people out, but I'll actually show you guys how to scrape data without using code through Google Sheets really simply in a couple minutes, okay? So that's the definition of scraping data. The next definition is structured data, and that's the word that I underlined in the last slide. But structured data, data that is organized and enables efficient access and modification, right? Refers to information with a high degree of organization. So the data sets that we're going to look at today are structured data. What is not structured data is when you ask, say, a company for data set, and they give you 5 figures, right? They're like, oh, 50% of people love our product, 60% don't, right? Something like that. Or a different variable, because that doesn't add up to 100, right? But 50% people love our product, 30% bought our product, 20% rented or something like that, okay? That's not structured data. Structured data is something that fits into a spreadsheet. It has rows and columns, and you're able to easily access the information through its rows or its columns, okay? So that's structured data. So with the next slide, actually, I want to ask you guys a question. This looks probably a little scary. It looks a little bit like the Matrix. But here's a question for you guys. Is this structured data or is it not structured data? It is structured data. Or is it not structured? Most folks agree that it is? Okay, that's really good. Because this is structured data. It looks like a mess right now, but it is structured data. And I'll explain to you guys why this is. It's a little hard for you guys to see maybe in the back or even in the front to see distinctively the data is on there. But if you look really closely, you actually are able to read things, right? So I see the word unavailable, ribosomes in control of gene expression, succeeding budget period, which stem from prior agreement. So if you look really closely, you see the data itself, but from a far view, it looks like just a jumbled mess, right? But the reason I bring this up is structured data in its most primitive form is through a file format called CSV. Are folks familiar with what CSV stands for? A couple folks. So CSV stands for comma separated value. And the first word is probably the most important, comma. If you look at this slide right here, and you look at where all the commas are placed, the commas separate the data in this screenshot right here, okay? So comma separated value in another slide, it separates the data into cells for us, right? So when you give a CSV to Google Sheets or to Excel, it works the same. The commas tell the computer what to separate. So name, comma, age, comma, occupation. You give that to a computer, and Google Sheets will know that name belongs in its own cell, age belongs in its own cell, and occupation belongs in its own cell. All right? And then second line is our data, right? So Denzel Washington is in quotes, and you're telling, and it's in quotes before a comma, and you're telling Google Sheets Denzel Washington is one cell. 63 is in its own cell, and actor is in its own cell again, all right? So commas, again, tell the computer how to divvy up your data, all right? So that's a CSV. I'm going to explain what a TSV is now. So TSV, the only thing that's changed is the letter T. Does anyone want to take a stab as to what the T stands for? Tab, right? So instead of using the keyword comma to separate our data, we're using a tab to separate our data now, right? So name, tab, age, tab, occupation. So it's a TSV now, right? Everything else remains the same, okay? And one more example, just to really hit the point home, we have a PSV now, and that P stands for pipe, right? The vertical line. Now you're telling the computer, look, we have the same data set, but we want to separate our data using pipes. So when you tell Google Sheets, our separator is pipes, and then Google Sheets knows how to divvy up our data. Name belongs in one cell, age belongs in one cell, and then occupation belongs in one cell. Okay, so quickly, that was what CSVs are, PSVs are, TSVs. You just have to tell the computer what is a separator value for our data set. And this is great because you could literally tell the computer any separator you want. Like you could tell the computer, I'm using emojis as my separator. I'm using a character or a M dash or something else to be a separator. All you have to do is provide the computer, and you have to tell the computer what is our separator value for this data set. But for our purposes, 98% or more of our data sets are going to be separated by commas, okay? So when you look for data sets, make sure you try to find something that is comma separated value because it will work with every single spreadsheet software available, okay? Now let's just quickly talk about Google Sheets and Microsoft Excel a little bit because I'm sure there's a lot of questions about why we're talking about Google Sheets and not Excel. This is what Google Sheets looks like. I'm sure you guys have all seen it before. Rows and columns, very organized, right? Microsoft Excel, roughly the same thing. There's just some data in there, but rows and columns, again, a little UI difference, but all the functionality is roughly the same. Okay. So let's talk about Excel real quick. Excel is better at handling large data sets than Google Sheets, all right? And a big reason for that is because it's a software that you download on your computer. Google Sheets is something that you access through your browser, through a Chrome browser, Safari browser, etc. But it's something that you handle through your browser, right? So Excel is something that you download. It's better at handling large data sets. Excel is great also because it has advanced functionality. I have a few friends in New York who work in finance or who do a lot of math, and they rely on Excel because it's able to do a lot of really complicated modeling and a lot of different advanced functionality that they need, but for our purposes is not that important, all right? And the third thing about Microsoft Excel that's a pro is it has faster overall performance. Again, that's because you download it as a software on your computer, all right? The biggest con for Microsoft Excel is that it is expensive, right? I know most newsrooms are able to provide their reporters, their editors, etc., with a license. But if you're a freelance journalist or something else, Excel is kind of hard to get a hold of, right? So the biggest con is that it is expensive. Now let's talk about Google Sheets real quick. Google Sheets is free as long as you have a Google account. Live editing with collaborators. At Vox Media, a lot of our apps that I build are all built off of Google Sheets. A lot of our editing structure is fed through Google Sheets. And that's because we really like kind of the live editing with collaborators. So also in my previous job, we would have just a huge spreadsheet with every single story that's coming out this week, right? And then we have a column that goes, has this been edited? Yes or no? Who edited it? Et cetera, et cetera. And we could have 10, 15, 20 people in that document working on it at the same time, right? And then integrations with third-party apps. I'm going to demo this a little bit when we do our hands-on, but there's a lot of cool add-ons to Google Sheets that really make your job a lot easier, all right? The biggest cons of Google Sheets is that it's slower just because it works in the browser and has fewer advanced functions. But for our purposes as journalists and cover the election and doing data journalism, that's okay, all right? So not just because we're here at Google and we're talking about Google Sheets and a lot of other Google tools. I think for our purposes as journalists, Google Sheets is the best thing. We collaborate with a lot of folks. We need to be able to send Google Sheets to folks and work on the same version of a spreadsheet and not have to email it back and forth. But also the ability to do charts, to do pivot tables, etc., with other people is a huge plus for Google Sheets in our kind of capacity, all right? So with that, I'm going to go into a couple spreadsheets that I pulled up for this training. And I want to kind of talk about some of my favorite functionalities of Google Sheets and show you a few tips and tricks that I use a lot in my kind of daily work. So I have a few spreadsheets that we're going to go through. But the first one that I'm going to show you guys now is this data set that I pulled from the DC Open Data Portal. Hopefully you guys are familiar with it, but most cities now, just about all cities now, have an open data portal. New York City has one, Minneapolis has one. I think just about all the boroughs in New York also have one, and Los Angeles, obviously. Most major cities in the United States have one now. So all you have to do is Google it, Open Data DC, and then you get access to a lot of open data sets that the government provides. All right? And one of them is this data set that I found, camera enforcement in DC. All right? And let's take a look at this data set real quick. It has all the red light cameras, auto patrol speed cameras, portable speed cameras listed in DC. So there are 135 of these things in DC, okay? So with this example, I'm going to show you guys how to do a pivot table. Have folks done pivot tables here already? A couple folks? Okay, for those who have not played around with pivot tables or aren't familiar with pivot tables, the best way to explain pivot tables is to know that pivot tables help organize or group data, all right? Group data, organize data, summarize data for you. Or another way to see it is that pivot tables help you answer questions you might have about your data set, all right? So looking at this data set, we have a couple columns. We have the enforcement, which is kind of the type of camera or what is being enforced here in column E. And then we have the address, we have the district that the camera enforcement is in, the ward, and a bunch of other data sets in here, including location, okay? So one question that I have right now is just how many auto patrol speed cameras are there compared to portable speed cameras compared to red light cameras, all right? And with a data set of 140 such cameras, it wouldn't be a good way, but we could manually add them all up, right? That wouldn't be efficient because we could do this very quickly with pivot tables. So I'm going to do that real quick. And pivot tables is something that's available in Microsoft Excel too. But data, pivot table, and it opens in a new tab. And what I like to think about pivot tables is how do I want this data to look when it presents the information for me? So I want auto patrol speed, portable speed, and red light, and all the other enforcement camera listed to be repeated once uniquely in column A of my pivot table. So what I can do is add the enforcement as a row in the pivot table. And now you see each one of these types of cameras are listed just once on column A, all right? And now to tabulate it or to summarize how many of each of these cameras are in this spreadsheet, we go to values and you can click enforcement, and now it will count A right here, all the different cameras in this data set. So auto patrol speed, there are 35 of these cameras. Oversized truck cameras, there are 2, right? So now we're able to answer that question really easily just by starting a pivot table that way, okay? Let's try to answer one more question that we might have in this data set. How many cameras are in District 1 compared to District 2, compared to District 5, compared to District 7, so let's say, okay? So we can start a new pivot table. I'm just going to remove these points from this pivot table. And I'm going to select the ward. So it lists each ward once, right? So wards 1, 2, 3, 4, 5, 6, 7, 8. And now I just want to count how many cameras are in each ward. I click on values. And let's just go back to ward and counts it. And now we can tell that there are 36 cameras in ward 5 and 26 cameras in ward 7. And there's only 4 cameras in ward 1. All right? So quickly, that's how to do a pivot table with data that lists out all, say, cameras or something else to answer these questions, to group and to summarize this data set. All right? So next up, I want to quickly, let's say I want to map out where these cameras are. All right, I want to map out where all 135 camera enforcement red light cameras are in DC. Right? If you look at this data set a little bit, you see that there are latitude and longitude positions in the data set, right? So every single camera, there's a latitude and longitude. And if you're familiar with latitude and longitude, it tells us exactly to a pinpoint location where these cameras are, all right? So now what we're going to do is we're going to take this data and we're going to go to Google My Maps and actually plot out every single camera in DC, all right? Before I do that, I just want to quickly demo for you guys a couple other examples of Google My Maps. So Google My Maps is one of the many mapping visualization softwares that are available through Google. All of them are free. Google My Maps is really awesome because it gives you everything that's already available in Google Maps. So I covered Google Maps a little earlier, but if you're probably familiar with Google Maps, it has biking directions, it has driving directions, walking directions, street view, all that stuff. So Google My Maps is just an extension off Google Maps where you can make your own custom Google Maps and share them, okay? So I want to quickly show you guys a few examples of Google Maps that I've really liked, that I've seen. In New York City, we have Time Out Magazine. If you ever come to New York, you see Time Out Magazine everywhere, and they tell you kind of what are the events happening any given weekend. So they kind of tell you what to do, what are some things to, where are some places to go every weekend. So there's a phenomenon in Manhattan called Manhattan Hedge. So every year, twice a year, the sun sets perfectly down the center of the buildings. So it's a really pretty sight. Everybody just floods the street to see the sunset perfectly between the buildings. So Time Out Magazine made a Google My Map where they just plotted out the 5 best locations to watch this event. And the best thing is they just dropped in the address and you could click it and you see what the street looks like. And then you could also add some quick blurb about this particular location as well. So for this one, Time Out Magazine said 42nd Street will be another good spot to watch this sunset phenomenon. Okay. Another example I wanted to share with you guys is, oh, not that one. So I'm a nerd, but I use My Maps a lot for personal things. But this is a really great example of using My Maps not just for journalism, but this kind of demos all the other features of it too, right? So my girlfriend and I were looking at apartments in New York City. If you ever have to find an apartment in New York City, it is a pain in the ass, right? And you see there are so many different dots of all these different apartments that we looked at over like 3 months, right? So what we did is we had our data set of every single apartment in New York City that we wanted to look at. That was our data set. We mapped it on a Google My Map. And for the ones that we saw that we didn't like, we put a red X on there. We added a custom icon saying we don't like this one. A green with a diamond meant that we liked it, but we didn't love it. And then obviously the heart means that we loved it, right? And we were able to quickly answer a lot of questions. Is this close to a subway? Is this close to work? Where is it located compared to all the other apartments that we were looking at, right? And then for the blue line is really awesome, and I mentioned this a little earlier. The subways are awful in New York. The DC ones are a little better, right? But we didn't want to rely on the subways to get to all the different apartments. So what we did is we let Google plot out a bike path for us to get to all our apartment viewings, and that is what the blue line is for. So Google Maps, as you're familiar, has bike routes built in. Google My Maps also has bike routes built in. You just have to provide it the address, and it will map out a bike route for you. All right, so that's what we did there. We biked to all these different locations, and we marked which apartments we liked more than the others. Okay. And then one more example I want to show you of a Google My Map is this one that I have. Another personal one, but I have a friend, he works at Google in New York too, so he knows all about the good stuff about Google My Maps, right? And he wanted to throw a surprise birthday party for his girlfriend. He wanted some input from some of his other friends, so what he did was built a Google My Map, listed a couple of the bars that he was considering. And then if you click on any of these bars, it actually has a full bar information built in, right? So I'm saying all that information about restaurants, about locations are all also built into Google My Maps. So you can add them and add custom locations in Google My Maps that way, all right? So now that I've shown you a few examples of Google My Maps, let's make that Google My Map of all the red light locations in DC. So the first thing I did was go to google.com/mymaps, and then I click create a new map, all right? And now we have a map of the United States to work with. Of course, it works internationally too, so if you need to make a map of somewhere else besides the United States, you could do that as well, all right? The first thing we need to give My Maps is our data set. And Google My Maps is built off of layers. So every single layer, this is our first untitled layer. Every single layer is a data set. Okay. So I will import our first data set, which is just that data set of 135 red light cameras. It's in my Google Drive. It is right here, DC training. And I will let Google My Maps fetch that data for us. And the first module that it kind of asks us to provide is, what is the location data for your data set? And if you remember, in this data set, we had latitude and longitude already provided, right? So all we have to do is provide Google My Maps with the latitude and longitude columns, which it already automatically detected, and say, use this location data to plot out the dots on this map, okay? Now I'm gonna hit continue. And then the second one, and the second and final one, is choose a column to title your marker. So when you click on a marker, what do you want them to say? For our purposes, I'll put the address on here. So when you click on a red light camera location, it'll tell you what is the address of this red light camera, all right? Now I'm gonna click finish, and then it's gonna take a couple seconds to start dropping all these dots over DC of where the red light cameras are. And we'll give it a second, and then, oh, I wonder if I did that correctly. Oh, I see what happened there. So we are in Antarctica right now, all right? So this is not DC, and I'm actually sure there are not any red light cameras there. But what I did was actually I flipped around latitude and longitude, right? So that was fun. But what I'm gonna do now is I'm just gonna fix my data really quickly, all right? So this is really easy. I'm gonna swap these around and go long here. And then I'm gonna go lat here. So I'm gonna flip that around. And now hopefully, oh, did I get that right? Yep. Don't wanna go back to our Antarctica. I'm just gonna delete this layer. It's really as simple as that. Delete this layer. I'm gonna re-import the data set where I flipped latitude and longitude back, all right? So let's do that again. Practice makes perfect. DC training, fetching Google Drive, and then again, we could do this again, all right? So let's try it. And let's see if we get out of Antarctica. All right. And there we go. All right. See, that was pretty easy, right? We fixed that. So now we have a location, we have a point for every single red light camera in DC simply by doing that, right? So all we did was we had the data set in Google Sheets. There was a latitude and longitude, and all we had to do was feed it to Google My Maps, and it did the rest of the work of dropping all the points over every single red light camera in DC for us, right? Yeah, do you have a question?
Don't give DC any ideas about putting cameras in Antarctica.
Yeah, no, I'm pretty sure that's out of the jurisdiction as well, so. So here's all our red light cameras. Right now, they're all blue, right? They're all blue. Did you have a question?
Yeah, so if you aren't given lat and longitude data set and you only have like a county zip code or something, is there a workaround for that?
So if you're already being given latitude and longitude, that's all you need.
Yeah, but what if you're not?
So, okay, so that's a really good question, and let's touch on that real quickly. So if you're not giving latitude and longitude, obviously latitude and longitude works all around the world, right? The best thing I say about latitude and longitude is that if you're doing a story about where the North Korean nuclear reactors are or something like that, they don't have an address like one North Korea nuclear reactor way, right? North Korea. That's where latitude and longitude comes into play because you have satellite imagery of everywhere on Earth. And everywhere on Earth, there's a latitude and longitude. So if you don't have a home address or an address of something, you have the latitude and longitude so you can map it, right? But if you don't have latitude and longitude, there's a process called geocoding. I guess I'll touch on that real quickly. So if you have just an address, say this one is 1900 Southern Avenue Southeast, right? And you give that, so what happens when you go to Google Maps and you type in an address, say 25 Massachusetts Avenue for this address, right? When you type that into Google Maps, hit enter, there's a process that Google goes through called geocoding. It's really fast. What it does is when you type in the address, you provide the address as a query to Google. Google looks up that address against a big dictionary of all latitude and longitudes associated with addresses, right? So if you look up 25 Massachusetts Avenue, there's already probably a latitude and longitude associated with it, okay? And once it gets you that, once you type in the address and it drops the red dot, it already has the latitude and longitude. That's where it knows where to drop that red dot, right? The familiar Google Maps red dot. But if you don't have the latitude and longitude, you have to geocode all the addresses here. And there's actually an add-on that I can show you guys a little bit. So I have it set up where you can highlight a bunch of addresses and click geocode cells, and it will automatically geocode all those addresses to latitude and longitude for you, all right? Just a quick disclaimer that geocoding is more of an art than a science. It's not perfect, okay? You can geocode state names as well. So if you geocode states, it'll just find the perfect center of every single state. It'll give you the latitude and longitude of the perfect center of every single state. But if you geocode states, there's always one state that falls into Europe or the Middle East. Does anyone want to take a stab as to what state that might be? Georgia, right? So if you geocode Minnesota, it drops a point exactly in the middle of Minnesota, point exactly in the middle of Iowa. But just because you give it Georgia, it doesn't know if you're talking about Georgia, United States, or Georgia somewhere else. When you geocode something, you want to provide as much information as possible. So if we want to geocode this column right here, we definitely want to provide the full address, such as 1900 block of Southern Avenue Southeast, Washington, D.C., United States. Okay? Question?
So I just got data from a FOIA that only gave me the block and the street. So for example, it said 55XX
Yeah.
Cicero Avenue. Is that enough information, or should I like make up an address within that block?
So, yeah, if you get an address of just a block, that's harder to geocode, right? So that block address is probably not in that long dictionary of all known latitude and longitude plus addresses, right? So you have to, again, like find the exact center. You have to give Google that block, and then it'll try to find the exact center of that block for you. But that's probably the best you can do if you don't have an address already, okay? Any other questions about geocoding before I go on? Okay. So obviously, if you have latitude and longitude, it helps a lot, right? You don't have to geocode. If you have to geocode 1,000 addresses, it's going to take a while to do, all right? I know that Google has a geocoder. Bing has a geocoder as well. And if you give it like a 200, 300 addresses, it might take 30 minutes to actually find the latitude and longitude for all the addresses, just FYI, right? So if you ever have a data set with latitude and longitude already, it saves you a lot of time. Yeah, landmarks.
We have work just went to Nepal, So if I knew the landmarks of like the places he visited and made a column of that, is Google smart enough to know the geocodes in them, like known landmarks?
Yeah, so if you give well, let's use landmarks, but in DC for an example, right? So the Washington Monument or you know Thomas Jefferson Memorial. If you give Google and tell to geocode based off those, it might be able to. But for ones in Nepal or somewhere else, I'm not sure. You just have to kind of try and see if it turns out. But that's the number one thing I say. After you geocode a set of addresses, make sure to check where the dots are dropped, all right? Like I said, when you geocode all the states, you see one always you see Georgia somewhere else, right? So like I said, geocoding is more of an art than a science. Make sure the information is verified and correct. I recommend that if you geocode a list of addresses, geocode it also through Yahoo, geocode it also through Google. Try to do a couple, pass it through a couple geocoding software just to make sure everything is falling where it's supposed to, okay? All right. Actually, one more quick thing I want to show you guys about latitude and longitude, since you guys are very interested about it, is how to get your own latitude and longitude. So this is actually really easy to do with Google Maps. And I use this a lot because, say, if you ever visit Central Park in New York or Prospect Park in New York, they're really, really large parks, right? And if you want to meet your friends there, you could be like, hey, meet me by Strawberry Fields or meet me by the Big Lake, right? That's not specific enough. If you really want to take it an extra level, you could, like me, provide your friend with a latitude and longitude. Type it into the Google Maps, and it'll take you exactly to where you are within, like, inches of accuracy, right? So how do you do this? Really easy. When you're on Google Maps, all you have to do is right-click. And then right here, third from the top, it says what's here, right? So I just clicked on a random street in DC. I right-click on the area, what's here, and you see the address and also the latitude and longitude is provided by clicking what's here. All right, so the latitude and longitude of this random street, 7th Street in E, latitude and longitude is 38.89, comma, negative 77.02. All right, so that is the latitude and longitude of exactly where I drop my mouse cursor on Google Maps, okay? So that's how you get latitude and longitude really quickly. All right, let's go back to my maps. I want to quickly show you guys how to change the colors of all these markers, right? Because right now we just see where all the red light cameras are, but what if we want to color code it depending on a different variable, all right? So I'm going to color code it on a different variable. let's say I want to color it by ward. All right, so one ward is one color, another ward is a different color. All right, all I have to do is click on uniform style, and instead of having all the markers be the same uniform style, I can decide to style it by a data column. So here I will style it by the ward, and it will automatically, Google My Maps will automatically pick a color for each ward. All right. Then obviously, if you want to change the colors too, you can. So hover over any of these wards, change the color. Or of course, you can also, like I did with the apartment map, change the icon as well. So I think those are some balloons for Ward 1. But obviously, you can go around and change to, there's a lot of different icons for you to choose from. All right. And I think there's actually a way to customize your own icon as well. You can upload a little icon for your My Maps as well. Okay. Did you have a question?
Yeah, that was my question.
Okay. Yeah, the icons are great, right? So a lot of different ways to play around with this and to kind of set up your data set that way. And let's just click on one of these icons. You click on it, and now you see the entire row of data that was in our spreadsheet, right? So we see the latitude and longitude, the object ID, the enforcement, so the portable speed, and the district and ward. Actually, I think a better way of coloring these dots are by what type of camera it is, right? So instead of styling by ward, I will style it by the enforcement. And now you see that red light cameras are red. That's good. And then that portable speed are orange, auto patrol speeds are yellow. So now we have a pretty good data visualization of all red light cameras, and based off the color, what type of enforcement they are. Okay? So if you want to share this, there's a couple really easy ways to do it. Click share. You have to give a title to this. I'm just going to type in some characters in my keyboard. And then obviously you can share it as a URL, or you can invite people and embed it as well as another way, okay? With that, I want to go back to my Google Sheet and talk about scraping now. Scraping is really awesome. I talked about scraping a couple slides ago, but it's essentially copying and pasting information from a web page automatically, right? So here I have a data set here of the list, the current members of the United States House of Representatives, and it's actually in a Wikipedia article. All right, so Wikipedia has a lot of great data sets. This is one example of it, right? So the list of current members of the United States House of Representatives. And you see there's a long table of voting members by state. So there are a few hundred, all listed here. Now, say I want to have this in a spreadsheet to play around with. I could copy and paste each line by line, or I can scrape it really easily using Google Sheets, and this is how you do it, all right? So there is a formula called import HTML. All right, and I'll do it quickly, and I'll go to a slide to show you exactly what it does. I'm gonna zoom in real quick. So equals import HTML, and you have to provide this formula 3 things in order for it to scrape that table in the Wikipedia entry for us. The number one thing is, what is the link that we're scraping? Right, the link is that Wikipedia article that I showed you guys. So wikipedia.org/list of current members of the United States House of Representatives, right? So that's the first what we call parameter, the URL that we want to scrape. The second parameter is what is the thing that we're scraping? Is it a table or is it a list? We looked at that Wikipedia page and we recognized that it was a table that we wanted to scrape. So I'm going to type in table in double quotes, close that, and that finishes our second parameter. The third and final parameter to scrape this list of members of the House of Representatives is which table is it on this page right here. So we provided Google with this entire page, and we look at which table this is. So I did a little bit of homework before this, and I recognized that this long table that we want to scrape is the 7th table on this Wikipedia entry. The other tables being this, being this, being this, right? So I recognize this large table is the 7th table on the page. So I'm going to provide the third parameter with 7, finish the parentheses, and then I have an error. It's just zoomed. It's zoomed out. It's zoomed in a little, so I'm just going to fix it real quick. But okay, so put the table in double quotes, and then 7. All right, hit enter. It's going to take a second, and now we have the entire list of data, right? So yeah, that was crazy, right? So good software should be like magic, and I felt like that was kind of like a magic act, right? So all I did was provide the Wikipedia entry, the URL, identified it as a table, and then told Google what table it was on the page, and all of a sudden, it gave us all 400 plus rows of data for us automatically, all right? So that was the election one. I want to do another one really quickly since today is NBA opening day, I'm a big basketball guy. And I want to show you guys how to scrape even without a Wikipedia entry. All right? So it doesn't have to be a Wikipedia entry that you have to scrape. This is a website that I found, NBA player stats. All right, so it lists every single player in the NBA. So there are over 400, I believe, players in the NBA with all their stats for the season. Not just 400, 605 NBA players in the NBA, right? And it lists all their stats here. This is a huge data set. And let's just say we want to work with this data set. We don't want to copy and paste all of this data into a spreadsheet. We want to scrape it, right? Because that's what we're talking about. How do we scrape this page, right? So remember, we need 3 things in order to scrape a page. Number 1 is that URL. So the URL is right here, NBAstuffer.com/2017-2018 NBA player stats, right? So we'll copy that URL. And the number 2 thing is, again, we need to figure out if this is a table or is this a list. And looking at this data set, we recognize that it is a table, right? Third parameter, the third and final parameter is which table is this on the page, right? Just a heads up, you can guess and check and be like, oh, type in 1 first to see if you get the right data. Type in 2 if you get the right data, and you can go on and on, right, until you find the data set that you want to scrape. But I've already identified that this is the second table on the page. The first table on the page is this one, right? This is just all the players that played in the playoffs and their stats. But we want the entire data set of every single player in the NBA and their stats, right? So this is table number 2. So I'm going to go back to my Google sheet, and I'm going to do the formula again. So equals import HTML. First parameter, again, is the URL that we're scraping. So it's that NBAstuffer.com, right? Just like that. Second parameter is, what is it? Is it a table or is it a list? We've already identified it's a table. And then third and final parameter is which table is it on this page? And we've already identified it as the second table, right? So we'll close that. We'll hit enter, and it will scrape all 600 players for us in a second, right? That was really, really easy, and it didn't have to be a Wikipedia entry to scrape. All right, you had a question?
So depending on how the website is formatted, how do we tell which table is
Yeah, so that's a good question. So the question is, how do you determine which table is it on the page that you're trying to scrape, right? So my best suggestion, and what I did for this prompt, is just a guess and check, right? You don't give up anything to guess and check, right? So if we just put in 1 here, you notice that we scrape a different table on the page, and you recognize it as the first table on the page that was the playoffs. Now, if you do the third table, it might just return an error or a table that you're not familiar with, right? So it says not available, right? So it's best guessing and checking if you can't just identify which table it is. And here we identify it as table 2, okay? So I would just quickly want to put everything together. We talked about pivot tables and we talked about scraping. Quick question?
So if you're playing fantasy basketball and want a live updated obviously their stats change.
Yep.
Would you make a new pivot table all the time, or I mean would you scrape it again all the time, or can you set it so it's automatic?
Yeah, that's a really good question. So we talked about scraping earlier. The question is, how do you automate scraping the data so it's always up to date, right? So there are ways to do this in Google Sheets. It's a little bit out of the scope of what we're talking about today, but there is a formula where you can update this on an interval. All right, there's a lot of different ways to customize Google Sheets. I wish I had more time to show you guys all the things that I do with Google Sheets. We have a thing at work where at SB Nation where I work, we do like NFL draft trackers or NBA draft trackers, right? And every single time a player gets drafted, we scrape that page of all the players that are being drafted, and we update the timestamp saying this is when it was last updated. So we built a script here on this page where whenever this page is updated, the time gets updated as well, right? So it's kind of just like a if then this that kind of thing, all right? So that's a really good question. So let's put everything that we talked about with Google Sheets together, all right? So we talked about pivot tables and we talked about scraping. So we just scraped all the NBA players, but let's get some better details of this data set. So what I'm going to do is I'm going to create a pivot table of this data set of all the NBA players last season. And I'm going to actually figure out the average team stats of every single player or every single team. So we have a data set of every single player, but I'm going to actually aggregate it, summarize it by teams. So here I'm going to click rows. I'm going to click team. And now we have abbreviation and a team for every, we have a row for every single team, right? So Atlanta, Boston, which I think is Brooklyn. That's right, okay. And then we have, let's see, where's Washington? Washington's at the very bottom, right? So all the teams are represented here. And now let's just start averaging out the stats a little bit. Let's see, what is the average free throw percentage for each of these teams, right? And now if you click here, we could actually do really easy math. Google Pivot Table will average the data for us automatically. I click on average, and now you see that Boston, the free throw percentage is 59%, which is not good, right? And it automatically does this calculation for all the teams here in the spreadsheet, all right? All right, so I want to get a little bit crazy with this data set, and I want to answer this question. Which teams play the most veteran players, and which teams play a lot of young players, all right? My favorite team, the Minnesota Timberwolves, they're going through a little bit of turmoil right now. They have a lot of young players, but I want to compare the Minnesota Timberwolves with all the other teams here, all right? So what I'm going to do is answer that question by adding values as games played. So obviously every team plays a certain amount of games, and then for columns, I'm going to make this a two-dimensional pivot table, and I'm going to add age as as a column, right? So now we're looking at this. Atlanta had 20-year-olds play 74 games. All right, Atlanta had 20-year-olds play 74 games, and had 21-year-olds play 56 games. All right, and then let's look at my Timberwolves. My Timberwolves had someone that was 20 years old play one game, and had 21-year-olds play 82 games last season. Now, obviously, there's 82 games in the season in the NBA, but there are several players playing each game, right? So these numbers don't necessarily all add up to 82. But you see, that's how we quickly answer the question, how many games did 21-year-olds play for the Minnesota Timberwolves last season, okay? One more thing I'm going to show you guys. So let's make a quick data visualization out of this, all right? So how we're going to do that is the teams that had younger players, or the players play the most games, we're going to shade it a little darker green. So what we're going to do is something called conditional formatting. So I'm going to actually just highlight all this data set with one finger. See if I can do it. Okay. And then I'm going to go into a new feature called conditional formatting. It's click Format, conditional formatting. And then we can set a color scale. All right. And let's go, the greener the box is, the greener the cell, the more games someone has played. Right? So now if we do that, we have a very neat data visualization. Let me just do this real quick. And now we have a very neat data visualization of which teams play the least number of, or the younger players, right? So here we have Cleveland. They had LeBron James last year. He's a little older, right? And you see there's greener all the way towards the end of that age scale. So we just made a really quick data visualization off a color scale using pivot tables, using data that we scraped, and using conditional formatting in a Google spreadsheet, okay? So we didn't even have to do any Google visualization software. All we had to do was set color scales in Google Sheets to build this chart here, okay? Is Nick here? I think I'm running out of time. I don't want to keep you guys from lunch. But let me just quickly talk to you guys. That went a little longer than I expected, but let me talk to you guys quickly about Google Trends, if that's okay with you guys. Hey, Nick, am I running out of time?
No, you're fine.
I'm fine? Okay.
I mean, you're just keeping people from lunch, but other than that.
Yeah, I know. But I'll try to make this fun and entertaining for you guys, all right? So another thing is, who here has worked with Google Forms before? All right, a lot of people, right? So really awesome thing with Google Forms is that when folks fill out your forms, it can be directly imported to, or directly exported to Google Sheets, all right? So if you do a survey of some kind or do some kind of polling, you can automatically get that data sent into, as the GIF shows, into a Google Sheets, all right? So start playing around to set up pivot tables, etc. All right? All right, so let me just talk about Google Trends. Google Trends is a really awesome tool, and I want to make sure we talk enough about this, all right? Google Trends tells us what people are searching for on Google. It gives us kind of the pulse of what people are looking for online, all right? What it doesn't tell us, what Google Trends doesn't tell us is how many folks are searching for a particular thing. It doesn't tell us how many folks are searching for lunch in DC right now, right? But it gives us a rough idea of how many people are searching for lunch in DC. And I'll show you guys a few examples of this in action, all right? But one of the things that is most confusing about Google Trends is what does it tell me exactly? And instead of telling you like 5,000 people are searching for lunch in DC, it gives us an idea based off of a value from 0 to 100, and it's called the Google Trends index number. So here's the quick definition of that. The index number represents search interest relative to the highest point on the chart for the given region in time. Second and third sentence are the most important. A value of 100 is a peak popularity for the term, and a score of 0 means that there was not enough data for this term. All right. So the highest the number will go in Google Trends is 100. The lowest is 0, which means not enough data. And 50 means that the term is half as popular as the peak. All right. So a few things about Google Search. It's Google Trends. It's a great data set just because of how many people are searching Google every single day throughout history, right? So we are able to access a lot of that information because everyone is searching through Google Search, right? So the size of it. My favorite part about Google Trends is its honesty, right? You're probably more honest with Google Search than you are with a roommate because your roommate will probably judge you, right? So if you don't know what gun control is or if you don't know what your symptoms are, you probably won't be as honest as you are with your roommate than with Google Search. And that's something that is encapsulated, that is captured in Google Trends. And I'll show a few examples of that. One other thing is the immediacy of Google Trends. So something that happened a couple minutes ago, we're able to see how people search for something that happened minutes ago, all right? So let me quickly show you a few examples of stories told with trends. This is a horse race chart of the Republican presidential debate a couple of years ago, right? And you see the minute-by-minute granularity of this chart, and you see who's controlling the conversation or who's controlling the Google searches at any given time, right? You see Jeb Bush kind of riding the bottom, and then Ben Carson, Donald Trump kind of trading places at the very top, right? So we're able to get this level of granularity of data through Google Trends, all right? Here's one, gun control explained. You don't see any Google charts or any charts at all here, but this really talks about the honesty aspect, right? So the New York Times knew that people are searching Google with more honesty. So they put together this FAQ, gun control explained, with the Google Trends team. What are the most commonly, frequently asked questions about gun control, and how do we answer it without embarrassing anyone, right? I'll skip that one real quick. This one is actually made by the Google Trends team, America's Most Misspelled Words. This was made during the the spelling bee competition a couple years ago. So every single state, if you're like me, I can't spell unfortunately at all. And every single time I spell unfortunately, I just Google it, and Google corrects the spelling for me. So apparently this is common behavior. And Google Trends identified it, so they made this map of the most commonly misspelled words by state. Minnesota has a hard time spelling beautiful, and Wisconsin has a really hard time spelling Wisconsin. All right. Here's a little more somber one. So this is a Google Trends comparison between two terms, gun control and gun shop. And you see that gun shop really has more search interest than gun control most of the time, right? And then we see two large spikes where gun control searches outpace gun shop searches, right? So this is an article in 2015 by the Huffington Post. Interest in gun control is fading, Google data shows. As usual, people appear to care in the days following a major shooting, and then they lose interest. So we're able to see that in the Google Trends data through that, okay? Here's a fun one. Search term popularity in New York between solar eclipse and my eyes hurt, all right? The total eclipse happened around 2 o'clock in New York. I was there for it. And you see peak interest for the solar eclipse peaked at the point of whatever, total darkness, right? And then right away, searches for why my eyes hurt spiked, right? So we're talking about that honesty aspect again of Google search, all right? And then one more, Google Trends, search interest for the eclipse was greatest where they had the total darkness of their solar eclipse, all right? So those are a few ways, really interesting ways to, really interesting ways people have used Google Trends in the last couple of years, right? So we did, Nick and I did a training in Minnesota. I'm originally from Minnesota. And this is a great debate over, is it called duck, duck, goose or duck, duck, gray goose, right? So it's like a very regional thing. And you're able to see the like regional differences through Google Trends, right? So you see that Minnesota is very gun-ho on duck, duck, gray duck. And everybody else is very adamant that it's called duck, duck, goose, right? If you're really curious as to why this is, it's because duck, duck, gray goose, or duck, duck, gray duck has more variation. So you could be like duck, duck, red duck, blue duck, and not pull the trigger on duck, duck, gray duck. So FYI, right? And then one more thing really important is for the midterm election, there's actually a midterm elections hub. So I'm actually going to take you guys to that real quickly. I think I actually have it on my next slide. it's kind of aggregates kind of the important questions that are being asked for each state's race. So DC is not available for here, but if we look at Virginia, you see that there are a lot of interesting localized maps, Google Trends maps. So search interest versus vote Democrat versus vote Republican in the past week. You see how all the different counties in Virginia react to that. And then also things like what are the issues, search interest in highly searched topics in the past week. Healthcare is a big issue in Virginia, according to the Google Trends data, followed by immigration, tariffs, abortion, and guns, right? So take a look at this. This is updated once a week. And then we see the search interest in highly searched topics in the past week again. This is just another look at the data here, okay? Before we break, I do want to show you guys a hands-on example with Google Trends. So I'm just going to go to Google, trends.google.com. And then this is what Google Trends looks like. If you haven't been to Google Trends before, this is kind of the starting page for Google Trends. There is a small team working behind Google Trends, and then they aggregate a lot of interesting things that are happening in the world. So it seems like Taylor Swift and Kim Kardashian is always up here, but there's always this interest in comparing Taylor Swift and Kim Kardashian, followed by the World Cup, football, American football, etc. All right. So I always like to start with this one. Who here played Pokemon Go when it came out a few years ago, right? A lot of people, I definitely did, right? I don't play Pokemon Go now, though, right? Does anyone still play Pokemon Go? It's okay. It's still fun, right? But here's the question. It seemed like everyone was playing Pokemon Go for a week or 2 weeks or 3 weeks, and then people dropped off, right? So let's try to answer two questions. When did Pokemon Go peak, and when did Pokemon Go kind of fizzle out? So we can do this we can try to answer this question as best as we can using Google Trends. What I'm going to do is I'm going to search for Pokemon Go. And then you see there's actually two options for Pokemon Go. One is Pokemon Go, the search term, and then one is Pokemon Go, the mobile game, right? I'll explain the difference between the two in a little bit, but I'm going to select Pokemon Go, the mobile game. And now you see Pokemon Go search interest in the United States for the past 12 months, right? Pokemon Go came out a couple of years ago, right? So we're going to change our filter from the past 12 months to say, let's try the past 5 years, right? And now you see a huge spike in Pokemon Go search interest in roughly the summer of 2016, and then it peaked and then kind of dribbled out, right? So let's set a custom time range. Instead of the past 5 years, let's go custom and go July 16th, 2016 to, let's just try December of 2016 and see if we can look more closely at the peak of Pokemon Go search interest. Oh, I'm going to back up a little bit. So instead of July, I'm going to go back to, let's say, April. April 16th, 2016 to December 2016. And then let's take a look at that peak. So now we can say accurately peak interest, search interest on Google for Pokemon Go was July 11th, 2016, right? And by September 2nd, 2016, Pokemon Go is 10 times less popular at that point, okay? So that's pretty awesome. And then if you scroll down a little bit, you could look at interest by subregion. So we see that Hawaii, there's the most interest in Pokemon Go. I'm guessing there's because a lot of good water Pokemon probably in Hawaii. Followed in Utah, California, Washington, and Oklahoma. A couple other things I want to point out, related topics and related queries. These are really awesome and really important. Related topics are things that might be similar to Pokemon Go. It's not in the same search, but it might be someone searches for Pokemon Go and then they search for Nest or Coin or Incense or Stardust, right? Related queries is my favorite. These related queries, when you search for Pokemon Go, you're probably not just searching Pokemon Go, Google, hit enter, right? You're probably adding a few more words along with it. So related queries kind of captures those words for you. So the most popular search for Pokemon Go in this time period was Pokemon Go CP. So I think that was experience points for Pokemon Go, where to get CP. And then the second most popular related query was where to get an EV, right? Things like this, all right? One more example I want to show you guys with Google Trends is actually something that was really interesting to me and that a student of mine found out. Google Trends, again, is really great at answering questions, right? Answering questions we might have, settling bets when Pokemon Go peaked, etc. One of my students wanted to compare General Tao's chicken with, yeah, I'm getting you guys ready for lunch. So General Tao's chicken, oh, did I just miss it? T-S, oh man, I should know how to spell this. General Tao's chicken versus orange chicken. All right, and check this out. Orange chicken. All right, so the dish, General Tao's chicken versus orange chicken, the dish, or the 2004 present. And look at that, we're very divided over if we call it orange chicken or General Tao's chicken, right? And this is not something that we commonly know, but if you look at it on a Google Trends map, breaking it down by geography, you can really see these things, right? You see that Pennsylvania is very pro General Tao's chicken, and California, very pro orange chicken, right? So speaking of the map, oh, and here, let's look at related queries real quick. So again, these are the words that are also being searched along with these terms, right? So a lot of people are searching General Tao because they want the recipe, right? Or they want to figure out what is a sauce and how to make General Tao's chicken. Compared to orange chicken, how many calories are in orange chicken versus crock pot orange chicken, Chinese food, etc. So this is really interesting, right? One more thing I want to show you guys about this map in particular is we don't have to look at this data from the United States. We can actually dive down 2 more layers of granularity. So if I just want to look at the breakdown of General Tao's chicken versus orange chicken, say Pennsylvania, I can click on Pennsylvania, and it'll break it down by the major metropolitan areas in Pennsylvania. So this one county, it's Elmira. Elmira. Is this New York? Oh. I guess it included the local, the next door major metropolitan areas as well. It's very pro General Tao's chicken, right? And then everyone else, there's more of a breakdown there, okay? We can actually drill down to one more layer of granularity as well. So if we want to click into Elmira, we can see it by city level too. Unfortunately, that one doesn't have enough data. Let me go back. If it doesn't have enough data, it won't lie to you. It'll just tell you it doesn't have enough data. But let's go to Philadelphia area. And then you can see the data broken down by cities, and we just have a few cities to choose from. So if we look at Philadelphia, 78% General Tao's chicken, 22% orange chicken, okay? Final thing about Google Trends is if you like this chart and you want to share it, right, there's a couple options to do this. So one is you could download this data as a CSV. We talked about what a CSV was. It's a comma separated value. You can upload it into Google Sheets. You can make your own visualizations based off it, right? The second one is to embed it. If you click on embed, it gives you a little embed code, a little iframe code. You can copy and paste it into your CMS, and it'll be interactive, and folks can play around with it. Here's what it looks like on mobile. And then finally, if you want to share it, you could click on the share button. It'll give you a URL to exactly this page, and if anyone clicks on that URL, they'll see exactly what you see on this page, okay? Any questions about Google Trends? Yeah. That's a really good question. I don't know if they can. Nick, do you have any idea if Google search can be manipulated by hackers or?
So we get actually this question quite a bit. It would be almost impossible for them to do that, and probably not particularly fruitful in that effort. You know, I mean, it'd be very, very difficult to actually do that. But we've gotten that question a few times. I'm actually trying to put together a blog post that actually talks about that specifically, because we've gotten probably about a dozen times in the last 2 months.
How many more minutes do I have? Can I get 10 more minutes?
I don't know. How hungry are these people? Can we give Frank 10 more minutes? He has been using only one hand this entire time. So,
thank you. One other thing I want to point out about Google Trends is that for folks who work in like audience development or anything, at Vox we use this a lot actually for SEO as well. So when we sports, right, you have acronyms and you have full spellings of things. So if we want to figure out what is the most searched acronym, say like TCU, right? TCU, Texas, I forget the rest. Christian University. Shouldn't have picked that one. I should have picked another one. But if you want to put a slug or a headline TCU versus the full spelling, you can see which one is searched for the most. All right, so that's an interesting use case for that as well. All right, so I want to hit on the last couple tools here. Election Databot is a really important tool for why we're here today. It's a tool built with a partnership between Google and ProPublica. You've heard of ProPublica. And they kind of pull together all the information you might want about the election into one app, and that's the Election Databot. So you go to this website, projects.propublica.org/electionbot, and you can go into your state's races and see all the, say, campaign finance, campaign filings, articles about a particular candidate, polling numbers, all through one website, one source. I think last night was the campaign finance filing deadline or something like that. I have a really good friend of mine. She works at the Washington Post, and she covers politics and money. And last night she sent sent me an Instagram video of her using the election data bot to get all the information she needed ahead of deadline. So all that is updated every 15 minutes with the latest information about every single candidate in this upcoming election. So definitely do not miss out on this, all right? It also integrates Google Trends data, polling data from 538, the Cook Political Report, Huffington Post pollster information, as well as forecasting data from 538, okay? So that's the election data bot. Data GIF Maker is more of a presentation of the data, right? So Data GIF Maker is really great because you're able to create very easily animated GIFs comparing two different data sets. So Data GIF Maker, here's an example of it. So we're comparing Schumer shutdown versus the Trump shutdown. And then all you have to do is type in the numbers, hit export, and it'll give you a GIF. That is great on mobile, that is great on websites, and you could tweet it, you could share it. Just one way to visualize the data that you might already have, right? So that is Data GIF Maker, all right? Tilograms is another mapping software that is available for free through Google Tools. It's a tool that makes cartograms, right? I touched on what a chloropleth map was, and that was the jawbone map of average sleeping time. That's where the counties, the US counties, are shaded according to the data variable, right? Here, cartograms, the data variable redraws the shape of the data set that you're trying to show, right? So if we're trying to show a data set of all the states in the United States, the states will get distorted depending on the data, right? So a cartogram is a distorted map. So here's an example of that, right? So these are really hard to make. Maps in general are really, really hard to make just because you have to have a lot of geographic information built in there. But cartograms are especially hard to make just because the distortion of these shapes are really complicated or almost impossible to do by hand, right? So thanks to the Google News Initiative and their partner Pitch Interactive, they were able to build this tool, Tilograms, that has been used by 538 and is by used a couple other news organizations to build cartograms, right? And the most important thing about cartograms are that it gives, well, we always see that map of which counties voted for Trump, which counties voted for Clinton in the 2016 election, right? And you see most of the country looks red. It's not because most of the country voted red, it's because the state sizes are larger on the West Coast, right? So you see more red compared to blue, right? So cartograms really tries to even the geographic sizes out to be more accurate as opposed to just throwing the shape of, say, Wyoming or throwing the shape of California on a map. So that's cartograms right there. And this is a free tool, Tilograms, to build your own cartograms, okay? So definitely check that out and play around with it. Here's a couple examples of it being used by, say, Washington Post here as well, all right? Last but not least, let me hit on a few final data visualization tools. There's obviously a lot more than we just covered. Flourish is one that Nick mentioned earlier. This is a new visualization library or new visualization tool. It's free. That was debuted last year. I've used this tool. I've taught this tool a little bit too. And what it does is it has a bunch of templates. It has several dozen templates for you to choose from. You don't have to make any of these things. All you have to do is click on one of these maps, say a map of London or a map of something else, Great Britain, Berlin, and just type in numbers into a spreadsheet, and it'll automatically build that visualization for you, all right? So you don't have to draw the map or create a bar chart or something else. It'll do that as long as you have the data and you know how to style it, all right? So that's Flourish, and it's a free tool. Google Dataset Search is also a brand new tool. It came out a couple weeks ago. I think it was 3 weeks ago now. It's a Google search tool. It's like Google Scholar, but you only search for data sets. All right, so it's really specific, and it's definitely worth playing around with g.co/dataset search. It searches through a lot of whitelisted Google data providers, including NASA, NOAA, et cetera. All right, so Google Dataset Search. That's still Google Dataset Search. OpenRefine is also a really good data set if you really want to get in the weeds of data journalism. As we probably talked about now, data is really dirty a lot of the times, and you have to clean it. Sometimes you have enough time to manually clean it, but OpenRefine is really great because it really helps. It provides a really big helping hand to cleaning data. So if you have a spreadsheet where, I once got a spreadsheet where there were like 8 different spellings of the word pizza, right? And instead of going through every single misspelling, finding every misspelling of pizza and replacing it, you can give a couple of the misspellings to OpenRefine, and it'll replace all the erroneous misspellings and fix them. All right, so OpenRefine is really powerful. Election Land is a project that it covers access to the ballot and problems that prevent eligible voters from casting their ballots during the 2018 elections. Check that out. And then Data Journalism Handbook, if you're not familiar, datajournalismhandbook.org. Then obviously, if you want to follow up on anything that we've covered today, g.co/news training. There's everything that I've talked about is also on there, plus more, so check that out. And with that, I think it's time for lunch. Thank you very much, everyone.
It is. Big round of applause for Frank.